So the way that we can talk about this, these many permutations, and the way that we can notate this 4 times 3 times 2 times 1 is to say 4 exclamation point. But we don't call this an exclamation point. We call this 4 factorial. So a factorial looks like this. If I had any number, n, then n factorial is n times n minus 1 times n minus 2 times n minus 3, dot, 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 until you get to 1. So if this n was 10, then it would be 10 times 10 minus 1, which is 9, times 10 minus 2, which is 8, times 10 minus 3, which is 7, until you get all the way down to 1. That's what factorial means. So now let's see if we can do some permutation examples here. So here's an example of a permutation. I've got 20 girls on a team. And I want to find the probability that Shanice will be number 1 and Renee will be number 2. Okay, so now here's what we're going to do here. We're going to find the probability that these two girls are going to be number 1 and number 2 on their sports team. So we're talking about like their jersey number or something like that. So here's step 1. Find the total sample space. So that would be 20 factorial. So first we do that. Step 2, find the total favorable outcomes. So the favorable outcomes that we want are going to be 18 factorial. Why would that be? It would just be 20 minus 2. We got this person here, that person there, so there's 18 left. So 20 minus 2. Step 3, is calculate the probability. So we put the favorable outcomes, 18 factorial. So we've placed Shanice in number 1 and Renee and Shanice in number 1, Renee in number 2, and so there's 18 left to place wherever. Who cares where all the other girls get their numbers? We're just concerned about Shanice and Renee. So there's the 18 over 20 factorial. All right, so let's do this the easiest way that we can. So let's start by listing off all of the numbers. So we've got 18 times 17 times 16 times 15, and we can go all the way da 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 all the way down over 20 times 19 times 18 times 17 times 16. Oh, wait a second. If I go from 18 all the way down, that's going to be the same as 18 on the top all the way down, right? So I could just cross those out, and this just becomes 1 over 20 times 19. So I end up with 1 over 20 times 19, which is 1 over 380. So they have a 1 in 380 chance of Shanice and Renee getting number 1 for Shanice, number 2 for Renee, and all the other girls get whatever number they get. Who cares? We only care about Shanice and Renee right now. All right, let's see if we can do another one. We're going to look at the first example. This would be a we try if we were together here. Look at first example. This example right here with the 20 girls. Find the probability. Oh, not the first example. That's the one up here with the photograph. The photo example. So we look at this. What is the probability that Troy would be on the far left, Dave would be at the far right? Okay, Troy on far left, Dave on far right. Find the probability of this happening. Okay, so there are 4 people up there, right? So find what the sample space is. So that was step 1, find the sample space. And that is 4 factorial. There's 4 people, there's 4 things being placed, so 4 factorial. And then find the number of favorable outcomes. And that is 2 factorial. And then we just put them on top of each other. 2 factorial over 4 factorial equals 2 times 1 over 4 times 3 times 2 times 1. Those go away, and I have 1 out of 12. So all I've done is I've placed Troy on the far left, I placed Dave on the far right. There are 2 other people to be placed, and who cares where they land, it doesn't matter. So that means there are 2 choices left, 2 factorial, and those go on the top. The sample space goes on the bottom, 1 over 12. Let's do one more. This would be another you try, I would say. Why not? I have a seating chart. And I've got a row of 5. Five students, so find the probability that Joe will sit in the front row, Janice behind Joe, Nancy behind Janice. So we're going to have 5 students in the row. Find the probability that Joe will sit in front. Janice behind Joe. And Nancy behind Janice. So we have these specific people, and they're going in specific order. So I have 5 seats. So it might be helpful to write them down. I have 5 seats. 1, 2, 3, 4, 5. I've got 5 students. And I want the probability that Joe will be here, and then Janice, and then Nancy. All right, so see if you can figure this out, pause it, and then I'll come back and help explain it and see how you did. All right, so my sample space is the first thing I need to do. Sample space is 5 factorial. And my favorable outcomes is going to be 2 factorial. Meaning I've got this one, so that was 5. This one is 4. This one is 3. So they all landed in the right spot. Now I have 2 factorial left. 2 factorial. And so now I put 2 factorial over 5 factorial. And that gives me 2 times 1 over 5 times 4 times 3 times 2 times 1. 2 and 1 go away, and I end up with 5 times 4, which is 20, times 3, which is 60, 1 over 60. Okay,